introduce you to our next speaker, I would like to remember you. We have some feedback questionnaire and herein. So we hope you enjoy and fill out. So now our next speaker is Ken Barber. He's the leader of the development team for Puppet Forge, working by Puppet Labs, and will introduce us to the modern module development, how we should write, and yes, beautiful.
Hi. Hello. So yeah, Ken Barber, Puppet Forge. So it's quite funny, really, because all the bad things that Patrick just talked about, we're trying to fix. So I don't know if anyone has met me before. Yay! So I might just start off talking about that. I mean, my talk is really about module development and module usage, but I can cut over to the Forge at any point in time. Pretty much all I ever do right now is think about Forge. So yeah. For those who probably already know me, I started off in professional services, and I spent a lot of time, spent a lot of time traveling to different customers, seeing the problems that they dealt with. I used to work for James Turnbull, and yeah, had a lot of fun doing it. But yeah, obviously, I looked at the product and I saw that it had a lot of problems that I wanted to fix. It's one thing to be a consultant out at customer sites and trying to help them with their case, but I felt like after a while it was like, well, it's probably time to try and fix it at the core. So the reason why I got into this Puppet Forge thing was really, literally, me complaining to one of our internal managers about how the Puppet Forge needs to be fixed. So yeah, it was like, all right, Ken, well, there you go, fix it. So yeah, the team's been around for about 3 months. We're very, very young. It was sort of started with just me, and slowly we've been bringing on other developers as well. We have, at the moment, we have one other senior developer, Peter Vanderbruggen. We've hired a UX developer, someone who can do the web interface stuff. We've got a product owner, Ryan Coleman. Who have I missed? Oh, and me. So yeah, we're very young. We realize that the Puppet Forge hasn't been maintained and hasn't been cared for, and I can fully appreciate that. And yeah, we're trying to make it better. So maybe at the end I can talk a bit more about it, and if you want to have Q&As, and if you want suggestions as well, because I'm open for it. Chances are I've heard it before, because I hear it a lot, and I've just been to PuppetConf over in San Francisco. But you know, just yesterday I had a couple of new suggestions that I hadn't heard about, so by all means, let's do that at the end, perhaps. But right now I want to talk about module development and usage, because Puppet Forge is nothing without content. That's the whole point here. So what is a module? A module is a distributable package that contains things like facts, classes, defined resources, Ruby resources, functions, things like that, okay? It's a way of saying, well, I've written this module to do something, I want to distribute it to users. That's it. It's not very complex. So Forge needs modules. You know, we've got about 556 or something like that now. But they need to be good quality. So this is the other problem with the Forge right now. So it's not good enough just to have a lot of modules. That doesn't help us at all, does it? So I'm going to be covering a number of tools today, and there's quite a lot of content, so if I speak really quickly, I apologize, but it's just that I'm trying to cover a lot of stuff. So RSpec Puppet for unit testing, Puppet Lint for checking your syntax, so it follows some code quality guidelines. I'm going to talk about the Puppet module face, or the Puppet module tool, as some people call it. Librarian-puppet, I'll give you a bit of a demo, and Puppet acceptance. The Puppet acceptance stuff's fairly new and fairly experimental, and it might interest a lot of people. And this is where I start getting into the crazy stuff that I would like to achieve. So before I start, let's talk patterns. So I'm just going to go through some patterns about patterns for developing modules. So patterns are important because, as Patrick was saying, there are different quality of modules, and sometimes people don't know how to write modules, for example. They don't know what pattern to pick or what pattern to use. So I'm going to walk through some patterns that I show you that I used myself. So this is important because we want to be able to reproduce the same quality module by module. New module developers, in fact new Puppet developers, often approach Puppet and then end up having to refactor it 3 times, 4 times, 5 times because they just they're not given a good pattern. And that's a criticism against us as well, totally. But this is why I do these sort of presentations. So these slides will be available online afterwards as well, so if you want to go back through them, by all means. So let's start off with class patterns. So, classes versus defined resources. Classes primarily are all about installing or setting up your environment for that particular application you wish to manage, okay? So the problem normally consists of installing, so that can consist of a file or a package, okay? Hopefully a package in most cases. It's often about modifying configuration files, or at least laying down initial structure for configuration files. So it might be directory structure, for example, setting permissions, things like that. And then finally, starting services. So we have a pattern for that. And if you haven't seen it before, we often call this pattern the package config service pattern. Some people call it package file service as well, but it's not always about files. Sometimes config can be not files. So package config service is the pattern I'm going to talk about. Now, diving right into Puppet code, the pattern that I'm about to describe breaks up this problem into three pieces, the package config service piece. So here, you're looking at an example of a class that deals with the package layer. And what the principle behind this pattern is to break up each of those three pieces into separate subclasses. So I'm going to use the bind example throughout all of these pattern talks. So in this case, we're talking about just package installation, all right? What I do ordinarily is I create a subclass called package, and that's the same for every module, and I put all package-related stuff inside that subclass, okay? Config, separate subclass, all config-related stuff inside that subclass. Thus also a separate file, of course. So as you can see, it's just a file resource. And I'll talk about where these variables come from in a minute. And then finally, service, okay? So three subclasses in this case. Now to bring it all together, I want a parent class that basically will call all of these three class declarations. Now to explain the syntax here, if it seems a bit wacky, the arrow syntax, if you don't already know, creates ordering. So it's, that would be the equivalent of this requires that, for example, okay? So it makes sure that these five things execute in order. The squiggly line is a notify. So in the case of a service, you can notify a service, for example, and if the config changes, the service gets restarted, all right? So this is shorthand. You could put requires and befores in here if you like, that's fine. I just do it because this is a fairly common pattern, and it saves me a lot of time doing it this way. And it keeps the syntax a bit succinct. The anchors, which I'll talk about, is on the next slide. So the anchors themselves, you probably look at them and think they're a bit strange. James mentioned it this morning. This is basically to work around a bug in the graph. I'm not going to go too deep into it, but basically it's necessary for this pattern. The anchor resource is a do-nothing resource. It actually does absolutely nothing on its own, like it doesn't change anything. But what it does do is it creates edges around the graph so that when you do build up dependencies between these main parent classes, if you like, it executes an order. If you don't have them, things break. Anchor's available in standard lib. I don't know if anyone's using standard lib, but I do recommend it. And yeah, so that's anchors. But we're trying to fix this in 3.0. So what you end up with is a graph that looks a lot like this. Package config service, all right? Define resources. So classes may do the initial setup, or at least the initial bootstrapping of an application, but you often want to fine-tune that application and configure that application. And normally that's done through either parameters to the class, or if you actually want to split things up into separate resources, defined resources, okay? Now, defined resources do fit into this pattern quite well. So this is made up. This doesn't work. This is not really how bind gets configured, but let's use our imagination. So this is a defined class called bind : zone. So the idea would be that if you wanted to maybe provision a zone with a defined resource, you would use some syntax similar to this. Now, the great thing about defining these coarse-grained blocks of responsibility, package config service, is that now all of a sudden you can insert things between them in the graph really simply. Modifying a service or modifying a configuration file like this using a defined resource, you're going to need the bind configuration. You're going to need the bind config done first, because bind config will presumably set up the directory structure and whatnot. But by just putting a notify here, that means that you're notifying the service, but instead of having to know beforehand what the service name is, for example, you just notify the whole class. You stop caring. You just go notify the class, please. If you use this pattern over and over and over again, that means you can stop thinking about the individual services defined in your manifests. You just say, I know that there's services in this class, just notify the whole lot. Doesn't always work, but it makes things a lot simpler. So what ends up happening in that case, in the graph, is that your zone file change gets inserted in the graph in the right order. Okay? So package config service pattern, good for about 80% of the time. Great for very simple cases, obviously. But a lot of the time it is simple. So if everything you do is packaged, which obviously everyone recommends, there's no excuse not to package things these days with FPM. You know, Jordan did a very good job on that, and really, honestly, if anyone tells you that packaging is hard these days, they just don't know about the tool. And yeah, the whole point here is that ordering is often something that's a concept that people struggle with, especially if they're new to Puppet. This kind of makes it very coarse-grained. You might need to worry about ordering within the class, like the config class might need a specific ordering or whatnot, but usually not. Laying down files often can be done in arbitrary order. And as we know, with the file resource, if you put a directory and then a file, like underneath that directory, Puppet will do the implicit ordering for you. So you start to forget about the ordering as much as you would have had to before. So instead of having one very large class with a lot of ordering stuff in it, you break things out and you've got coarse-grained ordering. So it's quite nice. I introduced this pattern to a lot of new customers and a lot of new people, and once they get it, once they have it down, it's literally a template. They just copy it to create a new module, and it saves me a lot of hassle. So it's good for new users as well, as long as you can get them to adopt it. But that's what I like about it. It's good for new users and good for advanced users. So yeah, it's worked for me. All right, params pattern. So params pattern is all about dealing with data that your module needs to configure itself. And what I like about the params pattern is it also deals with cross-OS problems as well. So if you've got multiple operating systems and you have to have a module that deals with lots of different operating systems, this is one way to do it. So every class obviously has a whole bunch of configuration items or data that makes up that class. And often you want to, within a class, and if you're using parameterized classes, you want to decide what the default parameters are. This pattern will help you with that. Most of the default parameters, like I've said, have OS-dependent parameters, so often you're more concerned about what the operating system is. If it's Debian, then you might need to change the package name, for example. Or different operating systems have different names for the same package. They might even have multiple packages for the same thing. So normally, what I've seen a lot of is that people will have a very large case statement at the beginning of their class that sort of does all of that logic. It says, oh, if Debian do this, if Red Hat do this. But again, just like with the package config service, you end up with a very large class with a lot of logic in it. And when people approach it, it's confusing. And it's not a pattern as well. It just looks like a lot of code, and people have to sort of grok it, and it's quite difficult. So as far as class parameters, there's kind of two different types of class parameters that you often get. There are user-tunable ones. So these are things that you probably do need to operate on or you do need to change. But yeah, the params pattern more focuses on the advanced parameters that need meaningful defaults but might need overrides. So let me show you a code example to explain the params pattern a little bit. Now, just like with the config package service, I've created a subclass. This subclass is called params.pp, or bind : params, sorry. Now, instead of that case statement that normally lived in your init.pp or in your main class, you can see that I've moved it off into a different class right now, okay? So what's great about this is that if people are looking for data or configuration variables, they know to always go to params.pp. Again, it's consistent. No matter if you were to adopt patterns like this, just like package config service, when people approach a new module, they can go, oh, where's the parameters? There they are. And again, it moves a lot of complication out of your main class. So in this case, let me walk through it. It's a case statement, operating system, and if it's Ubuntu or Debian, the package name, like I was saying, is going to be different, the service name is going to be different, and also the directory is different. But for CentOS and Red Hat, completely different. This is just a fall through. So if I don't know the operating system, I return with an error. That's because in this case, it's very hard to predict what the defaults should be if you don't know the operating system. Now to use this, basically in your main class, you would add the inherits bind : params. So you're actually inheriting from that class. Therefore, all the variables set in params.pp are now accessible within this scope. You create your parameters up here, just like you normally would in a parameterized class. But notice this usage here. You're actually providing fully qualified paths to the variables available in params.pp, okay? So what this is saying is it's going to be pulling those variables out of that previous file, this file here, okay? So all your case logic is here, and from this view, it's a lot simpler. Although this syntax is kind of nasty and repetitive, but we've got a solution for that, which I'll talk about later. What's great about this is that you've got a whole bunch of sensible defaults in your params.pp, but because it's a parameterized class, you can throw an ENC at it, and it also should work. Or you can, just when you declare bind, you can provide overrides if you feel like it. So it's fairly flexible. If someone doesn't agree with your params.pp and they don't want to provide a patch, guess what? They can override it. So in that case where they've got an operating system that isn't supported, you could potentially just manage it that way, all right? Without having to change the class, hopefully. Using this methodology, of course, it's going to fail, but if you were to remove that, most certainly. And, you're always going to run into cases where people are running weird operating systems, like Gentoo, right? Or Gentoo's friends. Solaris, yeah. No, but, Gentoo's weird, but then I start getting all these other variants of Gentoo, and it's like, Dragonfly BSD. Yeah, I used to work on Factor, and I have about, I used to work on Factor, and the amount of operating systems that we had to support there, as you can see, this is a smaller list than what I used to have, but yeah, like I'd say Dragonfly. That's because I actually had to launch the Dragonfly instance every now and then to test Dragonfly changes. Yeah, some people use it. It's great. It's not a bad BSD. Anyway, back to what I'm really talking about. Okay, so yes. So now that you've got these variables in your bind package, you want to be able to use them. But obviously, combining it with a package config service, that's going to be in separate classes. So if you do want to access those variables, you use this syntax here, bind : packages. Now, you're probably wondering why it's not params. That's because it gets evaluated here and set to these variables, and now you want to use that namespace everywhere else, okay? Or otherwise, the evaluation doesn't occur. And people can't override those variables when they declare the class. So all of those variables now appear in this manner throughout all your other subclasses. So some future stuff, or actually it's current stuff now, because Puppet 3 got released, and Hyra as well. We're trying to simplify this pattern, because this is fairly well established within Puppet Labs. We like it, and it's great, and all the rest of that. And this sort of stuff, it's very repetitive, and yeah. Ari Pina, who's a good friend of mine, who works in London, because I also work in London, by the way. Oh, not in London, but England. Well, you know, I say London to simplify things, but I actually live like about 2 hours out of London. Yeah, it's like yeah, I have to pack a big suitcase to get to work, yeah. No, no, I work from home from now. I don't go to London. It's a terrible place. No, I'm just kidding. So, you know, obviously people have seen this pattern and they've gone, well, this is great, but we're going to have to make it a bit better and solidify it. So Hira kind of came out a little bit out of this sort of pattern. I know people use it for a lot of other configuration items, but Librarian-puppet specifically was actually designed to try and make this pattern better. And, you know, the developers at Puppet obviously looked at that and went, well, how can we make this simple from a Puppet perspective? And that's where data bindings comes in. This is something available in 3. And the idea being that data bindings allow you to, if you are looking up a variable and there is no default or it hasn't been defined, it can fall back and look up in Hira instead. Okay? So it's quite nice. You don't have to use Hira functions to do things to look up. You can just define a variable, and if it doesn't have a default, it will fall back to Hira, which just cuts the syntax down a little bit, which is what I just said. So while this is future, people are still using 2.7.x. So it's great to think about this stuff, and it's awesome to experiment with it, but when you're writing a module that you need to aim at 2.7.x and 3, data bindings isn't there yet, so you know, you've got to be careful. But let me talk about a compatible or a backwards compatible methodology, perhaps. If you look at the params pattern on the left, that's the one that I've already showed you. If you wanted to use Hira, so you were looking up Hira to get the data, and then if that didn't exist, you wanted to look up in the params.pp, you would use something like this, and I'll explain it. Here, Hira, you're looking up bind : package. Data bindings uses namespaces to look up things in Hira. And then the second argument to the Hira lookup is obviously falling back to a variable. So this gives you, and this is documented on the, everyone's taking a picture, I was going to say. If you look up classes on the documentation site, this actually explains this pattern, by the way, in more detail. But again, even this is not that great. This still means you need Hira, but at least it's going to be 3 and 2.7.x compatible. Some people talked about a function, actually, that would live in standard lib and detect whether you were 2.7.x or 3. I don't know if it was ever created, though. Yeah, sorry, I don't have answers for that. Oh, and that's a mistake. Oh, no, it's not. No, that's correct. Never mind. So you've got to be careful if you're trying to use 3 features and you need it to be backwards compatible. That's what I'm saying. And this is the pattern if you want to use Hira in this case. So an example Hira file might be like this. So when Puppet 3 does do data binding lookups, it attaches a namespace to it for a class. So you can see this is what the data might look like in Hira.
So your previous slide is wrong then. Can you go back?
Yeah.
And after Hira, it's bind package, and for servers, it's bind package.
All right. I thought I changed that, actually. Well, yeah, thanks. Yeah, so yeah, package config service. No, package config. Is it wrong? Yeah, you are right. It is wrong. Never mind. If you want to learn more about data bindings and Hira and things like that, there was a really good presentation from Kelsey. If you get these slides, you'll be able to follow that link. Okay. All right. God, I'm going really slow. I'm going to have to go faster. You'll get the slides. Okay. Sorry, I've got to move. I said I'd speak fast, and I'm just chewing up too much time. Aspect-puppet. So I might have to skip a couple of demos. So Aspect-puppet is for unit testing Puppet modules and things like that. The concept is that within Puppet, it's all about catalog. Okay. What you want to do, what Aspect-puppet allows you to do is define a set of parameters for testing, and then check the state of the catalog and make sure it's doing what you think it is doing. So RSpec-puppet is great for unit tests, and it's able to test these 4 elements. Generally, it's used for, obviously in modules, it's classes and defined resources and functions. The layout is something like this. So if you want to test classes, there's an expected layout. Again, if you want to test defined resources, there's an expected layout for that. Let me speak quite quickly about this. So a class needs a lot of input or inputs. Obviously, some of them is facts. Like if you go back to the example I showed you, operating system was being used within the class. So in this case, for this test, I'm going to preload the operating system fact and just force it to CentOS. So when the test runs, it'll see $operating system equals CentOS. And classes take parameters as well. So whenever you define the test, you can define the set of parameters that you want to pass to the test. So this is everything from here up to there is just setup or initial. I guess it's the state that you want to test. The idea here is that based on what facts that you've passed and based on what parameters that you've passed to a class, you expect certain things to appear in the catalog, okay? For example, the simplest one is, does the catalog actually contain that class, all right? So this is a very convoluted way of saying, if I include this class with no parameters and just that fact, does it actually compile, all right? More complex examples. If I pass parameters and facts of a certain type, does my catalog actually install this package? Does my catalog actually contain this service? Okay. Templates are a good one to unit test. Based on these parameters that I pass in, for example, my config options live here, and I want to pass these options to the bind module. Does my template contain this regex? So this is a great way of making sure that your templates are working properly. Templates contain a lot of Ruby code and they have side effect, and it's a bit scary, but this is one way that you can ensure that your template's doing the right thing, okay? Because sometimes the slightest change in your template might break it. And this is kind of you can create guarantees through creating these tests that the right thing is happening. So setup for RSpec-puppet. I'm not going to go too deeply into it because I'm running out of time. You need to include a spec helper file in your directory like this. And you need to create a rake file that contains this kind of content. And then once you do that, within your module, you can run rake spec, and that will run your RSpec tests. So let me just quickly show you what that might look like. So I've got a series of tests here, some class tests. So again, I'm passing the operating system CentOS, and I'm passing no parameters for this initial block of tests. I'm testing here whether the class exists. Again, like I said, that's just a really basic way of saying, does the class actually get included? That'll pick up really basic compilation errors. Does the package, given that there's no params and the operating system is CentOS, is there a package bind being installed? Is the service bind? And again, you can see the template test there that I've defined before. And also, this one's a good one. This is like a negative test. Basically, I'm saying, if I try to pass the options test, it should actually fail. So the idea is that it should raise an error. So running that test now. You can see that green means good. Yellow is a pending test, so I'll come back to that. Or yeah, that means it isn't implemented yet. But you can see that by running that, everything is successful. So, moving on. Okay. Importance of good coding style. All right. Code is written more than it is read. I think Guido said something about the ratio is 1 to 4. He probably just made that up. But he's right, it is important to have good coding style. If you write really bad code, people won't want to, help you, basically. They'll look at your code and go, oh, it's hard to read. And so it's really important to get the style right. We created a style guide for that reason. This was probably a year and a half ago, a year ago. Obviously, we debated internally and said, well, this is sort of the style guide that we want. Tim Sharp from GitHub, great guy. Just met him a few weeks ago. Spoke to him online for like a year or something like that, but finally met him face to face. Yeah, he's another Aussie as well. Yeah, he wrote this tool called Puppet Lint, which I'll show you in a second, and it basically validates your code for style. The great thing about this is that instead of having debates about style, instead of your colleagues saying your style is bad, this tool will just give you a green light or red light, right? So no arguments, it either passes or fails, which is really good. I think style is not so much the problem, it's just that as long as you're using the same style, I think that's the point, all right? I mean, you know, you can have tabs or 4 spaces or whatever it is in any language, but as long as everyone in your team is doing the same thing, then we're happy. It's when different people in your team are doing different things, like someone's using Eclipse and you're using Vim, that's when it gets to become a nightmare. So the way to use it, gem install puppet lint, and basically, again, with a rake file, you add this line, and then you can run rake lint, yeah? And I'll skip this one, but that would be the output. It'll actually tell you when you've got code style violations and whatnot. Okay, I'm just gonna skip this one because, yeah. Just a brief note on this. I was gonna talk about how to package for the Forge, but what we're working on very, very soon, James mentioned a tool, a command line tool, or Puppet module tool to be able to publish. That's one thing. We're also working on a GitHub integration so that you can just tag a module and we receive a service hook and we publish for you. That'll be nice, won't it? So that's one of the things that everyone asks for. I think it's like something like 80% of our modules actually have code hosted on GitHub. So we're kind of like, if we did this, right, and people just tag their code, they don't have to do anything else. It just appears on the Forge. Yeah. So, you know, that seemed like a really straightforward one. But command line tools also in the work as well, also in the works as well. So yeah, I won't go into this. Let it be known that packaging a module right now is a manual process. Puppet module tool. Sorry, I'm rushing because I'm running out of time. But if you haven't seen it already, the Puppet module tool allows you to search for packages or modules on the Forge. So, you know, there are a lot of different commands. For example, if you just wanted to search for a module, Puppet module search. This is really more like a Yum-inspired type of command. If you wanted to see what modules you already have in your module path, you can just do list, for example, and I'll show you the revision. If you want to uninstall something, see, this is what happens when you rush. Yeah, it's uninstalled, so again, yeah, it does all the things you expect it to. And it downloads from the Forge. Exciting. Cool. So, Puppet module tool is great. It's manual. You know, it's sort of it's actually inherited from an old tool that James was involved in and Kelsey took on and integrated into Puppet. And that's awesome and everything, but it doesn't solve the problem of trying to manage modules in your Puppet environment. So as Patrick mentioned briefly, and I'll give a quick demo of, there's this tool called Librarian-puppet. Again, Tim Sharp. we didn't need to hire our own people. We just get Tim to do everything. This Librarian-puppet is a tool inspired by Bundler, and if you don't know Bundler, the concept is that you can create a config file that you define all your modules and whatnot to be downloaded and installed. This is great, and it's much better, like Patrick was saying, than submodules. Some people use subtrees as well, but they really just suck, and this is such a nicer way of doing it. So let me show you how it works quickly. So I have a Puppet file here. Yeah. Some modules that are on the Forge at the top. Sorry, let me make that bigger. So the mod means download it from the Forge. Sorry, the two mod ones mean download it from the Forge, but this example here means grab it from Git. So if you're using Git internally, for example, well, there you go. So now that you've got that file in your root directory, so normally you'd put it in your Puppet, etc. Puppet, for example. You can just run Librarian-puppet install, and if I have internet, no, wait. I was going to do verbose, let's do verbose. So you can see it downloads, it follows dependencies. Yeah. So it's running all the necessary commands to set up the modules locally, okay? Oh, and you can see here that it's also following dependencies as well. You know, if you mention, like we've actually specified apt as a Git repo, even though it is a Git repo, it's still being able to look at the app's module file and follow the dependencies as well, which is great. So he's done a great job on it. So in this instance, it's awfully slow though. That's the problem. I don't know if it's the internet or what. Generally downloading stuff from GitHub, for example, in a production environment, yeah, not a great idea, because if GitHub goes down and you're trying to do releases and whatnot, and GitHub does go down, it's great system, but yeah, obviously they have problems, everyone does. I don't know if there's a solution, but really, if there was a GitHub-style cache, that would be pretty awesome. But, you know, I've seen lots of manual-style solutions that are pretty nasty. But yeah. But yeah, if it's your own content, your own Git repo, that's the best way to do it. It was much faster up in the hotel room, I tell you what. You know? All right, let's come back to it. Okay. All right. Ooh, I am down to my last subject. Good. All right. System testing. I don't really, I mean, lots of people have talked about system testing for Puppet, but I'm yet to see a really good solution. So, you know, I've been thinking about this a lot, and everyone's been talking about system testing. And the thing is that we've always sort of had a tool for doing this at Puppet, which is really quite strange. So what is system testing? System testing is about running the code that you've written on real machines and making sure the expected result actually occurs. This is not unit tests. Unit tests are just test, for example, with spec Puppet, all it's testing is if the catalog's right, which is fine in most cases, yeah? Most cases, right? But as soon as you go and do something strange, like, you know, have an exec resource, for example, or you write a Ruby type of provider that actually manipulates the operating system, suddenly unit like spec Puppet is not going to cut it. Even doing unit testing, like just pure spec on Ruby types and providers, what you end up doing is mocking what it's doing on the operating system, but that doesn't prove shit. It really doesn't. And you're just going to run into troubles all the time. I mean, you know, at the end of, I work on Puppet Labs firewall a little bit when I have the time. And the biggest problem I had is I kept getting regressions. Why? Because Red Hat 5 sucks. Their IP tables implementation is completely different to it's very old. And so people will patch something, and it'll work for Red Hat 6, work for Debian, blah, 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 blah. But Red Hat 5 is different, isn't it? Because it's an old version of IP tables. So unless you run the tests, or unless you run tests on these operating systems for real, you can't prove that this thing is actually going to work. Now, I could spend time trying to run this every patch on every single operating system manually, but that's arduous, and you know, I don't have the time. Let's see how this is going. It's still going. Oh, that's terrible. My next example is probably going to fail too because the internet's slow. But all right. So to help with this, we've got this tool, and like I said, this has actually been around for a long time. All right, and this is fairly out there. All right, this is fairly. I'm not going to say experimental, but you know, this is for the hardcore. But one of the things I want to do is I want to make this better. So we've got this tool called Puppet Acceptance, and for many, many years we've been using Puppet Acceptance. I wouldn't say many, many years, but a few years we've been using Puppet Acceptance to actually test Puppet itself. What it's responsible for is running Puppet or running shell commands on real systems to emulate things and then test if the results actually worked. Let me give you an example of how you would write one of these tests. So within Puppet Acceptance, you would configure all the agents that you might want to run. So these are servers, and they might be, maybe you've got a server for every different operating system, for example. In this case, you get a variable or a method called agents, which is just an array of these servers. What we want to do is we iterate across each of those. So say you're testing across 12 different operating systems. And here you want to say, on host, run something, and this is just a shell command, and then make sure that the result, or the standard out for that result, is going to match this regex. So what's actually really happening here is that for every host that you've configured for Puppet Acceptance, it's going to SSH in, run this command, check the result of standard out, okay? Now that in itself is probably not that useful. But what if you can run Puppet? So this is the DSL that we've written. We can actually run a Puppet manifest on all of those boxes that you've chosen, run a shell command, and make sure it actually bloody worked. Do you see what I'm saying here? So these are real tests. This is not emulated. This is for real. So it's enough to talk about it. Let's actually see it in action. Oh, look, it's finished. All right. So yeah, as you can see, look, all these modules have been installed, right? All dependencies have been installed as well, by the way. All right, so Puppet Acceptance. So let me describe the environment a bit. I have a Vagrant environment on my laptop with about 5 different VMs running. Now, currently with Puppet, what we do is we have a lot of VMware nodes out there and EC2 nodes out there that are just sort of sitting around to do this. But what I've done with Firewall to try and improve the firewall testing situation so I don't keep regressing is I've created a Vagrant file basically so that people can get up and running and they can download they can download Puppet Labs Firewall. There's some instructions that they can follow to get the environment set up so that they can actually run these acceptance tests themselves, okay? So in this case, you know, I've got a Vagrant file. As you can see, there's 5 boxes. I happen to have 1 Puppet master and 4 different agent nodes to run them on, and they're different operating systems, okay? Now, if you're really curious, I built these using VWE, so the VWE definitions are in this directory as well, and I checked the whole lot into Git under the Puppet Labs Firewall project so that other people can reproduce these boxes as well, all right? So the whole idea is that I want people to be able to reproduce this test environment, so community contributors can just download this and go. So that's how I set up the boxes. So you've got to have boxes to run these acceptance tests. So that's that part of it. The actual acceptance test part is a separate issue, I guess. What you've got here is, just to show you what directory I'm in, acceptance/vagrant. Underneath acceptance, I've got some tests here, basically. Oh, sorry. Underneath acceptance, I've got a series of test files that follow the similar format that I showed you before. Let's just have a look at one, for example. Let's talk about create multiple rules. And as you can see here, hopefully you can follow this, but what I want to do here is on each box, I want to run that Puppet manifest, which is actually going to execute real Puppet code on each of those nodes. And in this case, I'm creating 2 rules. And then you can see here that I'm actually doing a regex match on IP tables to see if it was actually created for real, okay? So it's a really simple pattern. Run some Puppet code, run a command line tool, and then test the output. And you know, I've got a few tests here. Oh, here's a good one as well. A lot of people forget this when they're developing resources. So the Puppet resource command, running that on its own, on say Firewall, for example, a lot of people forget to test that because you know, you may be able to apply rules, but running Puppet resource actually introspects the machine and then tests if the results are true. In this case, this is actually a clever way. Here, I'm creating the rule manually first, but the real test is, if I run Puppet resource firewall, which is what this little bit of DSL does, this just runs Puppet resource firewall on the command line, does the output match this? So you can see that I've got tests for running Puppet code and then running some scripts to see if it worked. Now I've got the reverse. I'm actually running IP tables itself, creating the rule manually, and running Puppet resource firewall to make sure that Puppet can see that it was installed. So I'm testing it in both directions, because literally that's what resources do. They don't just make changes, they also introspect the current state. All right, so I'm over time, sorry. But let me run this test. Let me run the actual, oh, come on, history. Ah, there it is. I think that's right. No, it's not. Okay, that looks about right. All right, so I'm going to run the tests. I have debug mode on, yes. So this is what the tests look like when you actually run them. Yeah. Ah, yeah, okay. All right. Sorry.
Testing is really easy.
Yeah, it's easy. No, the problem is that a lot of what I'm explaining right now is really complex, and we need much, much better documentation around it. It's that simple. Bloody serious. No. Oh, no. Oh, God, what have I done? Again, this went much smoother in the hotel room. God. All right, let's try this. All right. Yeah. Here we go. All right, so let me explain what it's doing. And that coloring is really bad, isn't it? Oh, I'm sorry. Gray. Yeah. This is it. So I'll just explain a little bit about what it needs to do. This is terrible. Gray. God damn it. Talk faster. So sorry, there's grey text there that's doing lots of stuff. But I'll fill you in with what it's actually doing. First of all, it's sort of bootstrapping each environment, okay? So obviously the ability to be able to run Puppet means that it actually has to install Puppet. And in this case, what it actually does is it checks it out from Git. So what's great about that is that you can run tests that run on Puppet 2.7.x, Puppet 3, Puppet Master, so the actual latest development version of Master, which is great. Same with Factor. Same with your own code. So you actually provide a series of Git repos that you actually want to check out and run all this stuff. Right, and that was within that sys-test example that I showed you. So first of all, it needs to set up the environment. So what it actually does is I start with plain machines, and when I built these machines, I do bugger all to them. All I do is install Git and SSHD. It starts with plain machines, does all the Git checkouts, and then does everything necessary. It sets up the Puppet master, so it runs Puppet using Webrick, for example, gets that working. And then all the clients, it'll deal with first SSL signing, all of that sort of stuff that you need to get, I guess, a working emulated Puppet environment up and running. Once it's done that, then it runs the tests that I've described. So this is probably going to take ages and probably going to fail because it actually needs to get out to the internet. But, gray. So yeah, while this is running, any questions? Because this is it. This is all I've got. Hey, man.
You said you had the vagrant definitions available in the Puppet Lab firewall module, but it cannot.
It's in a branch. So the question was, where are the vagrant definitions? It's in a branch that I haven't merged in yet.
So it's not actually on GitHub.
It's on my GitHub clone. So let me merge it in after this. Next question.
The design patterns, you mentioned that one is the params pattern is actually in the documentation already, but is anybody interested in putting up like something like the style guide, really a reference point for a reference in the documentation where to collect patterns?
Oh, that's probably a really great idea, and it's not something that I know about. Probably if there isn't already a ticket for it, raise it, obviously, but maybe you might want to actually raise it up on Puppet users to get some attention around that. I can obviously bring it back. There has been some talk internally, but the best thing you can do is actually put an email up on Puppet users and say, are we doing anything about patterns?
And maybe it should start on the wiki like the style guide as well, and then be moved.
Yeah,
later on
yeah.
maybe.
So what I've been doing is obviously going around and doing these presentations, and they're going to be up online. Oh, look at that. And this is going to be up online, and so I've kind of been propagating it in my own way. And what did someone describe it as? They barbarized their modules, because my last name's Barber. But yeah, right now these presentations are very good. I think there's been other blogs about this pattern as well, but you're talking about formal documentation really, so that's different. Go again. It's all right.
Yes, but please come to an end.
Just shortly, because I mentioned earlier that I think another important aspect for a new way, like high quality module set, would be a shared namespace. Is there any intention to work on that?
We're talking about it. We're talking about it. We're debating it. There's two camps. That's probably the nicest way I can put it. All right, so I'm just going to wrap up really quickly. As you can see, I attempted 5 tests and 4 passed and 1 errored. And that error was actually intentional. The whole reason why I went down this road is that I kept getting a regression, and that test that's failing there emulates the failure. So tests work. Great. I haven't fixed it yet, though, so that's why it's erroring. Okay, I gotta go. We're done.